Hi, my name is Pat Monteith, and I'm a solar system ambassador, which means I'm a volunteer for NASA and the Jet Propulsion Laboratory. And I go through a lot of training by NASA to be able to present information to you just like this. And tonight we have a very special program. Let me see if I can stop that and then go to that. There we go. We have a special program tonight called Look Up and See about the Perseids Meteor Shower. And the Perseids are actually happening right now for the next several weeks. And I'll tell you what that means and how you're going to be able to see it, and especially how you'll be able to see it at the peak of the meteor shower, which is going to be happening the middle of next week. You know, think about it for a couple of seconds. You know, in ancient time, objects in the night sky conjured superstition and were associated with gods and religion. But misunderstandings about meteors lasted longer than they did about most other sky objects. Meteorites, which we'll talk about more in a few minutes, which are the pieces that make it to Earth, were long ago thought to be cast down as gifts from angels. Others thought the gods were displaying their anger. And as late as the 17th century, many believed that they fell from thunderstorms, and they were actually nicknamed thunderstones. Many scientists were skeptical that stones could fall from the clouds or the heavens, and often they simply didn't believe the accounts of people who claimed to have seen such things. In 1807, a fireball exploded over Connecticut, and several meteorites rained down. By then, the first handful of asteroids had been discovered, and a new theory emerged suggesting meteorites were broken bits off of asteroids or other planets. And that's still a theory that still holds. And we're going to be talking about all sorts of things like that tonight. So what is a meteor? Well, plain and simple, a meteor is a space rock. It's a rock from outer space. And depending on its position in outer space or in the atmosphere of Earth, it could also be called a meteoroid or a meteorite. And I'll do what I can to try to make that as clear to you as I can tonight. We've got a couple of really fun videos that will hopefully clear up any misunderstanding that you might have about this. Now, I know there's a lot of youngsters in the audience, and so I thought I would start with a simple overview for the kids in the audience about what we're going to be talking about tonight.
Squeaks and I built this awesome observatory recently, and we love using it to look at the night sky. If you've ever looked up on a dark, clear night, you probably noticed that there are a lot of things to see. You can see the moon, the stars, and even some planets. And if you're really lucky, you might even get to see a meteor, a streak of light that bursts across the sky. Since the light that meteors make looks kind of like the bright light that stars make, a lot of people call meteors shooting stars. But meteors aren't stars at all. Stars are big balls of gas way out in space, far, far away from the Earth. But meteors are caused by pieces of rock and metal that are pulled close to the Earth. It all starts when a small piece of rock or metal breaks away from something bigger in space. Most of the time, these pieces are small, not much bigger than a grain of rice, and some are only about the size of a piece of dust. When the pieces fall toward Earth, they're going so fast that they heat up all the air around them and burn up, making the air glow. That's the light that we see in the sky. It's a little piece of rock or metal burning up. We call the falling piece a meteoroid, and the light that it makes is the meteor. When the meteoroid is completely burned, the meteor is gone and the light disappears. If the piece is very small, the light might only last for less than a second. If the piece is larger though, the streak might race the whole way across the sky. And if the piece is large enough, it can make it all the way through the layer of gases around the Earth and hit the surface of the Earth. If it does, then it gets a new name, a meteorite. I know, that's a lot of words that sound almost the same, but they're all different. The meteor is the streak of light. The meteoroid is what we call the bit of rock or metal as it falls, and the meteorite is what we call it when it hits the ground. Thousands of meteorites fall to the ground every year, but most of them are really small, so we don't even notice them. And there are even more meteoroids that burn up before they can get to the ground. During certain times of the year, there are a lot more meteors than usual. There can be 60 of them in an hour. That's called a meteor shower, because there are so many meteors falling through the sky that's almost like we're taking a shower in them. I know, that is kind of funny. Can you imagine taking a shower and falling rocks and dust? I think I'd rather stick to water instead. Meteor showers happen because of something else in outer space called a comet. Comets are usually very far away from the Earth, all the way out at the edge of the solar system. But sometimes one passes close by, right near the path where Earth moves around the sun. As it passes by, some dust from the comet breaks off, and the dust can stay in that spot for a really long time. Every year when the Earth gets close to the spot where the dust is, lots of the dust falls toward the Earth, and each little piece of it creates a meteor. And that's when we get a meteor shower. There are a few different meteor showers all throughout the year. There are big ones in January, April, May, July, August, October, November, and December. So there are lots of chances to see them. In fact, Squeaks and I are just about to get to see one of the biggest meteor showers of the year, called the Perseids. The best nights to see it are right around August 12th. You can ask a grown-up to help you find out when you'll next be able to see a meteor shower. Then all you'll need to do is find a dark spot, look up, and enjoy the light show.
Okay, so let me give you some science behind what's happening with this, because that went by kind of fast and you might not have understood the whole thing. I know I was very confused when I first started learning about meteors and meteoroids and meteorites. So let me see if I can make it easier for you. So Earth's atmosphere is made up of many layers, as you can see here on this graphic. And the layers of air, as it gets closer to the ground on Earth, gets thicker. And when that happens, when space rocks hit this area that I have circled called the mesosphere, they encounter enough friction from that air that they heat up and they start to burn. So what happens is, as the meteoroid comes closer to Earth, Earth's gravity pulls the meteors towards us. Most meteors become visible at around 53 miles up. You can see that up here, right where that mesopause dotted line is. They speed through the atmosphere at, believe it or not, 30,000 miles an hour and reach temperatures of 3,000 degrees Fahrenheit. That's pretty hot. If you were watching the space, the commercial space rockets and air travel take off a few weeks ago, Richard Branson had made it to 50 miles up, and then Jeff Bezos actually made it 62 miles up in the thermosphere. So there's a lot there that we could go into more details about, but we're not going to do that right now because we're going to stick here and talk about the Perseids meteor shower and meteor showers in general. So space rocks are called different things based on where they are in the atmosphere, as I mentioned, or if they land on air. So in general, a meteoroid is a space rock out in outer space, the upper beyond our atmosphere. A meteor is a space rock in the atmosphere, the upper atmosphere. And then a meteorite is a space rock that actually hits Earth or lands on Earth. Before they enter our atmosphere, they're called meteoroids. And I'm going to say this several times just so that you understand it. And hopefully you won't be too confused by the end of the presentation. And then when they enter our atmosphere, they're called meteors. Sometimes meteoroids don't vaporize completely in the atmosphere. In fact, sometimes they survive their trip through Earth's atmosphere and land on Earth's surface. And when they land on Earth, they're called meteorites. And if we were in person at the library, and I apologize that didn't happen tonight, I would have a bunch of very interesting rocks, and maybe they're meteorites to be able to show you. But that didn't happen. And so here's some pictures of some, and we'll talk more about the different ones. Okay, so, you may hear the phrase shooting star. You may have looked up and said, well, wait a second. Is that thing shooting through the sky called a shooting star, or is it called a meteor? Well, actually, a shooting star is a meteor, and those two words are used interchangeably. And so, if you see something shooting through the sky, you could call it a shooting star if you wanted to, or if you would prefer, you could call it a meteor. I've got a fun little music track right now that I'm going to play for you that gives you a little bit more detail about shooting stars and meteors and meteorites, and maybe it'll help you better understand or remember the difference between them all. Rounds like that. And I thought that was a cute song, and that you might enjoy it. All right, so do you know what a ton is? A ton is very heavy. A car is a ton. Scientists estimate that about 50 tons of meteorite material falls on the Earth every single day. Isn't that amazing? Almost all the material is vaporized in Earth's atmosphere, leaving a bright trail, which some people, as I said, call shooting stars. And so we'll talk about that more in a little bit. And the fact that you can see meteors every single day, depending on where you are and how dark it is, and all sorts of different situations. So, we're going to be talking about meteor showers tonight. And I found this really short, interesting news clip from ABC News that might give you a little bit more of information about what a meteor shower is. There you go. So, meteor showers occur when lots of dust particles or particles from asteroids or comets enter the Earth's atmosphere at very high speed, all at the very same time. And when they hit the atmosphere, meteors rub against air particles. They create the friction, as we saw a little while ago, heating them up. And then the heat vaporizes most meteors, creating what we call shooting stars. And what you see here is a picture, a real photo that was taken out in some property in Wyoming, where you could see the Perseid meteor shower and a real shower happening out there. I've had the opportunity to see some meteor showers in very dark places, like out west, and it's just breathtaking, absolutely amazing. And some of these can, as I said, produce a few meteors per hour. or up to 1,000 meteors per hour. And I'll show you where that actually happened once in history. So you can actually see meteors in the sky on any night because, as I said, scientists estimate that about 50 tons of meteorite material fall on Earth every single day. And it's still amazing whenever you stop and think about that. So on this next slide, you can see what's happening with the Perseids meteor shower. And we'll talk about the Perseids in a few more slides. The Perseids happen on a yearly basis, and they're named after the constellation the meteors appear to come from in the night sky. The one next week, and we'll look a little bit at constellations. I am certainly not an expert on constellations, but I'll show you a little bit more and give you some more information about it. And as I said, in this case, the Perseids meteor shower is because the meteors seem to come from the constellation Perseid. And there are, in fact, several meteor showers each year. So this is what is actually happening, and you'll see this in another video. So here's the Earth orbiting the sun. The comet's orbit actually intersects the Earth's orbit, and as the comet is disintegrating a little bit, then all the dust and rock and other material from the comet actually intersects the Earth orbit. The meteor showers are predictable because the Earth passes through comet orbits at the same time every year, believe it or not. But as I said, the comet orbits are full of debris, and that's what causes the meteor shower. So a comet, as you learned a little while ago, is a solid body like an asteroid, but it's composed of ice, rock, and frozen gases. And comets actually come from much further in the outer planets than meteors do. Meteors come from the asteroid belt between Mars and Jupiter, but comets come from beyond, let's say, Pluto, but Pluto's no longer a planet, but out in that further area of the solar system. And as the comet approaches the sun, because there's a lot of ice that's made up of comets, there's glowing tails of vapors that appear as the comets heat up. So this gives you an idea of the orbit of comet Swift-Tuttle. And Swift-Tuttle, that comet is what produces the meteor shower, the Perseids meteor shower that we're going to be seeing next week. On the left here, you see the list of major and a couple of minor, but some major meteor showers throughout the year. The three biggest meteor showers are the Perseids, which happen depending each year between August 11th and 14th. The Leonids, which are November 16th through 18th, and the Geminids, December 12th through 14th. Now, the Perseids are considered the biggest one, well, because it's during the summer and you can actually go outside and enjoy the meteor shower without freezing cold. I have, in fact, gone out and watched the Leonids and the Geminids and froze my fingers off. And actually, one year I remember giving up because it was so cold out there. Anyways, we were talking about constellations. There are 88 constellations out there, which have been in existence for many, many years. And, great significance have been given to the objects seen in the sky here. And throughout human history and across many different cultures, names and mythical stories have been attributed to the star patterns in the night sky. So that's why they're called constellations. Our ancestors may have recorded their view of the night sky on the walls of the cave. And how we know that is archaeological studies have identified possible astronomical markings painted on the walls of a cave system in southern France for more than 37,000 years ago. Over half the 88 constellations recognized today are attributed to ancient Greek, consolidated from earlier works by Babylonians, Egyptians, and Assyrians. They were actually all noted in 1930 by the International Astronomical Union, which shows star maps that mark lines and patterns that represent the shapes that give the names to the constellations. I don't know about you, but I, in fact, can pick out very few constellations. And that's not something that I've studied over the years. I can pick out the Big Dipper. You can see the Big Dipper here. In the middle, Ursa Major is supposedly a big bear. I guess if you look at that carefully. And I'm not going to go into the rest because it just isn't going to quite work out that way. The Perseids were named after their finding in the year 1862 by Lewis Swift and Horace Tuttle. Now, an interesting thing about Swift, he was working on his parents' farm, but at the age of 13, he fractured his hip in an accident. So for the next couple of years, he didn't have to work on the farm. And so he devoted more time to studying than farm work. And in 1850, he developed an interest in microscopes, and a few years later built his first telescope. He became fascinated by comets after seeing a brilliant one in 1858, and that comet was the topic of his first scientific paper. He went on to become a professor at the University of Pennsylvania and discovered 13 comets and over 1,200 previously uncatalogued nebulae. Horace Tuttle was an American astronomer and an American Civil War veteran. He was born in Newfield, Maine, and when he was 8, his mom died, and 4 years later, his father remarried and moved to Cambridge, Massachusetts. His brother Charles was an amateur astronomer who had constructed his own telescope, and on a visit to the Harvard Observatory, and if you've never been out there, I strongly suggest once they open up the observatory, you go. It's an incredible observatory. But anyways, Charles impressed the observatory director and was hired as an assistant observer. However, the following year, Charles was forced to give up his astronomical career because of failing eyesight and was replaced at Harvard by his younger brother, Horace. So both Swift and Tuttle found many comets and asteroids. And what you're seeing up here is the Mount Lowe Observatory, which Lewis Swift ran for 20 or 30 years. And on the far right, you could see the sketch of Swift actually sitting on this ladder that he had created, looking through the telescope up into the night sky. And every Perseid Meteor is a tiny piece of the comet Swift-Tuttle, which swings by the sun every 135 years. All right, so, we're talking about comets and asteroids and, the meteors and meteorite, and you might still be a little confused. I found a really interesting video that might give you a little bit more information about the difference between them.
They're part of action and sci-fi movie plots. We wait out in our backyard to see them showering over Earth. But what's the difference between comets, asteroids, meteoroids, meteors, and meteorites? Let's start with comets. Comets are basically big balls of dust, rock, and metals, surrounded by a thick, icy shell orbiting our sun. And when comets get too close to something hot, like the sun, their ice sublimates, or goes instantly from a solid to a gas. This creates a halo-like glow around the comet, called the coma. And our sun's strong solar winds blow the coma back, giving the comet their infamous tail. Comets can be classified as either long period or short period, depending on whether or not their orbits are longer than 200 years. Comets have highly elliptical orbits, which means they're like a long circle. In fact, some comets can be taken almost completely out of the solar system before they return again. Next are asteroids. Basically, asteroids are just comets without the ice. Just dust, rock, and metal. Most asteroids form in between Mars and Jupiter, in a region called the asteroid belt. While asteroids are rarely directed at Earth, they do pose grave danger to our planet. After all, 65 million years ago, a city-sized asteroid hit near Mexico and caused the dinosaurs to go extinct. Then we have meteoroids. Meteoroids are just pieces of rocky space debris floating around the solar system. Technically, meteoroids are larger than a grain of dust, but smaller than an asteroid. However, most meteoroids are usually only the size of a pebble. Most meteoroids also come from the asteroid belt, but some do come from our moon or even Mars. Next are meteors. Simply put, meteors are just meteoroids that actually hit Earth's atmosphere. We know these better as shooting stars. As a meteor hits our atmosphere, it burns up, causing a big flash of light in the sky. In fact, the term meteor from ancient Greece literally means celestial phenomenon in the heavens above, which refers directly to the flash of light itself. Even though they appear as big shooting stars, meteors are actually only the size of pebbles. Last but not least, meteorites. A meteorite is simply a meteoroid that successfully makes it through Earth's atmosphere and hits the Earth's surface. Meteorites are dangerous simply because they're too small to be detected. They come without a warning. And even though meteorites are usually very small, around the size of a pebble, they're still very dangerous because they travel at high velocities. Fortunately, it's very rare for a meteoroid to actually make it through Earth's thick atmosphere. Thanks, Earth.
There you go. All right. So now that you have a good understanding, and when I talk about meteoroids versus meteorites, you probably have a better understanding than you did at the beginning of this presentation. So let's get down to the nitty-gritty of watching for the Perseids next week. As you can see in this graph, the Perseids can actually start being seen at the end of July, depending on where you are, if the sky is dark enough, and you can actually see them through mid-August. But the peak of them, as you can see, is going to be on August 12th. So that's a week from this Thursday. Let's talk about some tips. I'm going to give you some tips for the best way to observe not only the Perseids, but any meteor shower that you might be looking at some time in the future. So here's some meteor shower observation tips. I've got 6 tips for you. Here's number 1. Don't try, bringing your head back to look up. Don't sit in a regular flat chair. What you want to do is you will get tired of doing that quickly, and you'll also hurt yourself. And I can tell you a story about my hurting myself, but trust me. The better thing to do is to lay on the ground or lay on a picnic table or reclining chair or a car hood. And in fact, I have laid on all of them. And I remember lying on a car hood on one of the beaches on the South Shore. I can't remember which one. But the best way to look at the meteor shower is to be in a horizontal position. Tip number 2, plan to stay for a while. The later you can stay up and the darker it is around you, the better you are. So if you go out at 1 o'clock in the morning, and I have fallen asleep regular time and then have gotten up 2 or 3 o'clock in the morning to go outside and watch for a meteor shower. And the darker it is. So if you've got a lot of lights around you, and I'll talk about that in a second, it's not impossible, but you're going to end up seeing more meteors if the surrounding area around you is darker. Now, the big thing is typically it takes a half hour for your eyes to adjust. And I say that to people, and I was like, no, my eyes will adjust in 10 or 15 minutes. Not really. It'll take about a half hour for your eyes to adjust to the darkness that you might be in. So you want to plan to stay out for at least an hour. I know I've been amazed where it's been about a half hour since I was outside, and then all of a sudden I could see a meteor here and another one there and another one somewhere else. And that's when you typically start seeing them. Here's a picture of a meteor coming in over St. Louis, Missouri. So while it's very difficult to see a lot of meteors, especially some of the smaller ones, if there's city lights, it's not impossible to be able to see a meteor like this one coming in over St. Louis, Missouri. And as you can see, there's about as much light pollution as you could imagine right there. All right, so tip number 3, be comfortable. You don't get extra points, or you're not going to see extra meteors if you're cold, if you're hungry, if you're thirsty or bored. Bring blankets and pillows, food, drink, and music. And more importantly, during this time of year, you want to make sure that you have bug spray, depending on where you are. So if you, go in the, park over in Hingham, let's say, and you're planning on going and looking at the meteors there because it's nice and dark, you're going to need a lot of bug spray. So don't forget to take that. Don't use anything that's got a screen like your iPhone to be comfortable, though, because not only is it going to kill your night vision, but it's going to distract you from looking up, and you'll miss something really important. I was out looking at meteors about 2 years ago, and somebody who was with me turned on her iPhone, and all of a sudden there's all this light pollution that came in, and it obliterated what we were able to see for close to another half hour. All right, so here's a tip about using naked eye and naked eye events. So meteor showers are referred to as naked eye events. And no, I didn't say for you to be naked, for your eyes to be naked. Of course you wear clothes, but don't put anything on your eyes like a telescope or binoculars. You'll want to see as much of the sky as possible at once. And telescopes and binoculars actually will narrow your vision. The meteors come from all over the sky, even though they say, they come from, it appears that they come from the center point of the Perseids. But by the time they enter our atmosphere, they could be off to the right, off to the left, behind you, or in front of you. It's amazing. And, I call them ooh and ah moments where, it's like, oh, look at that one. Well, because, you might have had binoculars, you missed it because it was off outside of the vision of your binoculars. Tip number 5, expectations. If you go out expecting to see 40 meteors an hour, unless you're in a really, really dark area, that's probably not going to happen. But some meteors are really, really amazing, even here in Brockton. I go out almost every year during the Perseids on my back porch, the back deck, and I see typically 15 or 20 meteors. Some of them are really small, and as you saw in that video, maybe they last a second. But I've also been able to see meteors that go right across the sky, some with various colors, like green, like you're seeing here. And it's just absolutely amazing. I love watching the meteor shower. Tip number 6, very young children are probably not going to be patient enough to enjoy a meteor shower and may prevent you from enjoying it. If they're looking for your attention and you're not looking up at the sky, you're looking down at your child, then you probably, I remember when I was much younger, missing a big, beautiful meteor from what I was told because I was paying attention to something else. So if you are going to have a child along, get creative about some non-light emitting activities, snacks, binoculars that they can play with, and maybe look at other things. All right, so when you look up at the sky for extended periods of time, you may notice other things as well. You can see in the bottom right-hand corner, you might see a fireball, which, I would just love to be able to see. It's much larger and brighter than a meteor and appears to move very slowly across the sky for a long period of time. In the upper right-hand corner, you might notice something moving. It looks like a star moving, but it's likely a satellite. There's a lot of satellites up in the sky right now, so it's not unheard of to be able to see something that looks like it's a star moving, and it's not. It's actually a satellite. There's also almost always a planet in the sky. If you'd like, you can download the free planetarium software called Stellarium to determine what else might be out there to look at while you're waiting for meteors. Now, one of the things that I would typically talk about is, when I talk about satellites, is one of the things that you might be able to see is the International Space Station. But that's not going to happen this year, and I'll explain that in a minute, and I'll give you some more information about that. But if you could see the ISS, here's a video from astronauts on the ISS that give you a little bit more information about what's going on up there and how you can spot the ISS, the International Space Station.
Did you know that we're traveling at 5 miles a second? We're going around the Earth so fast that we orbit it every 90 minutes. That means on the space station we see 16 sunrises and sunsets each day. Every one is magical to watch. But more important than the view, we depend on the sun's light to power our space station, and we use massive solar arrays to soak it up. Those arrays are so large that when the sun's light glints off them, it's possible to see us from the ground. That means you can look up in the sky at dawn or dusk and see our spaceship flying overhead. So take a few minutes to step outside, spot the station, wave hello to us, and remember what we represent. People from across the globe committed to working together to improve life for everyone on Earth.
Yeah, I'd love to be able to go on the ISS or in space, but I get motion sickness. Anyways, so in researching for whether or not you could see the International Space Station next week, I came across the sighting location. I went to spotthestation.nasa.gov, or you could do a Google search for ISS Spot the Station, and you'll get to the same page. You put in your sighting location. In this case, I put in Brockton, Mass. And it gives you a list of ISS sightings that are possible, in this case, from yesterday, August 2nd, through August 17th. And I was totally blown away to see that tonight, August 3rd, take a look down in the bottom where I have it circled. Tonight, August 3rd, at 9:08 p.m., you'll be able to see the International Space Station fly overhead here in Brockton. Now, it's going to be visible for only 5 minutes, So, you might want to get out there at about 9 o'clock so that your eyes can adjust to the darkness. It's lower on the horizon than it might typically be. Other times of the year, it could be at, 45 degrees maximum height. But it appears 10 degrees above the western at the western area, and then disappears. It goes for 5 minutes, maximum of height of 18 degrees, comes back down to 10 degrees and disappears above the south. Now, if you have an iPhone, then you probably have, an app that will give you a compass. If not, you should probably be able to bring it down. But, oops, no, it doesn't want to open for me right now. But if you have a compass app, there it is right there. You're able to, turn it around and figure out where's the west if you don't know which direction it is and where the south is. But it's really cool to watch, to look up and see the International Space Station. In a way, it looks like a satellite, but it's much brighter. It's really obvious to see. But make sure that you're looking tonight, if you're looking tonight, that you're looking low down on the horizon because it's not going to go up too far. But if you go to spot the station on a regular basis, you'll see that it, comes around every couple of weeks. You're able to look at it. And as I said, you'll be able to see it at different heights and different distances and whatever. But this is one of the things that I love looking at every so often. About once a month, I'll go out and just look up to watch the International Space Station fly overhead, which is neat. Okay, so over the past couple of weeks, there have actually been several surprise, unexpected sightings of big meteors. One of them, as you can see, was a week ago Sunday on July 25th at 5 o'clock in the morning over Norway, which is typically very, very dark sky. And there's this meteor you can see coming up on the upper left-hand side of the photo, and it lit up that section of Norway, not too far from the capital, Oslo, as if it were daytime. And I could show you many, many photos where this happens. It's unexpected. They didn't know it was coming, but it was big and bright enough that it showed up. Later on that same night or sometime that same day, if you take a look at the picture in the bottom right-hand corner, you'll see that there were 150 reports of this bright meteor with a green tail flying over Texas, but not only Texas, but also Oklahoma and Louisiana. So there was this great big fireball with a green tail streaking across the sky. So you never know when this is going to happen. And sometimes out of the clear blue sky or night sky, a meteor shower can be so big that it's actually a meteor storm. So back in 1888, there were no cameras to be able to take pictures of this. And on the right side here, you'll see a drawing of the Leonid meteor storm of 1888. They're much less predictable than meteor showers. And if you happen upon one, you might think it's the end of the world because everything is raining down on you. And there was an account from November of 1966 in Southwest United States that described over 100 meteors per second. And it lasted most of the night. And those were remnants of Comet Tempel-Tuttle. And when the Earth passed through it, somehow this big meteor storm ended up happening. All right, so, some of you might be saying, well, are meteors dangerous? Well, not too dangerous. As I said, meteors become meteorites if it hits the ground. And if it hits the ground, it could hit a person or a car. And while there's a lot of wild claims, there's really no cases that we know of where somebody has been killed from a meteorite, even though, these situations here could have been, the one on the right could have been a serious situation. The one on the left, a 14-year-old boy, was hit in the hand by a meteorite after seeing a flash of light, and you can see the scrape on his left hand. And you can see the size of that meteorite. Wasn't very big, but it still caused some damage to him. The picture on the right, you can see in the upper right, a meteorite that was about a grapefruit size crashed through a roof in a house, bounced off the furniture, and landed on a woman who was sleeping. And it caused some, as you can see, it caused some real dangers, some real problems. And that's a real photo. We're not sure if that counts as a hit, but maybe if you give the couch an assist, we could count it. All right, so got a few more slides I want to share with you. Actually, the next video I find probably the most interesting. It gives you a lot of information about meteors and meteorites and some of the history. It's produced by the National Geographic Society. So as you can imagine, it's really a wonderful video. It's about 3 or 4 minutes. We'll watch this, and then I'm going to give you some information about some handouts and how you can get some handouts and giveaways that we had planned if we were going to be doing this live. So here's the video right here.
Nearly 50 tons of space debris crash onto the Earth every day. While some debris shyly dissipate into the atmosphere, others display a spectacular light show. Meteor showers occur when the Earth's orbit intersects with the orbit of a comet. As comets travel, they leave behind trails of rocky material, oftentimes the size of pebbles or grains of sand, but sometimes as large as boulders. Every year, the Earth crosses these trails of debris, known as meteoroid streams, and the planet becomes sprinkled with rocky material. The debris then race through the Earth's atmosphere, creating friction with air particles and generating vast amounts of heat. This heat vaporizes and illuminates the debris as they fall, creating streaks of light in the sky, popularly known as shooting stars. These celestial light shows are often named after the constellation where they appear to originate as seen from Earth's surface. Meteor showers that seem to fall from the constellation Perseus are called the Perseids, and those appearing from the constellation Gemini are called the Geminids. About 30 meteor showers can be seen from Earth throughout the course of a year. And because the showers are timed with Earth's orbit, the celestial phenomena are cyclical and occur at regular intervals. For example, the Perseid meteor shower happens every August, and the Geminid meteor shower happens every December. Meteor showers have inspired awe and admiration for millennia. In Christian tradition, the Perseid meteor showers symbolize the tears of a saint, Saint Lawrence, who was executed in August of the year 258. And in the 1st century AD, the astronomer Ptolemy believed that shooting stars were a sign of the gods looking upon mortals and listening to their wishes. Inspiring everything from making wishes to reveling at the sky, meteor showers are a reminder of our place in a dynamic and beautiful cosmic ecosystem.
There you go. All right, so if we were live in person at the library, we would have had lots of handouts for you, including the bottom right-hand side, information, general information about meteor showers. The bottom left-hand is the sticker, the NASA sticker. Believe it or not, that NASA sticker is called a meatball sticker. Don't completely know where that came from. I guess it looks like a meatball. I'm not sure. There's a word search puzzle. There's a color by number, asteroids, comets, and meteors. And then my favorite are the solar system trading cards. And there's information on the back side of each one, beautiful pictures on the front. And we've got a bunch of these handouts for you. You can, while they last, you can get them in one of two places, either at the Brockton Library. If you get a hold of Sue McCormick in the children's room at the Brockton Library, she has a bunch of these. And also Pastor Richard Reed at the North Baptist Church on 899 North Main Street. I know he was going to be bringing a lot of people over to watch this presentation if it was live at the library. So I decided to give him a bunch of these handouts as well. So I hope that you have an opportunity to go over and pick up these handouts and you'll get one of each. They're really, really cool. That really does it for me, pretty much. I want to say thanks to NASA and the Jet Propulsion Laboratory for the creation of the Space Station Ambassador Program, which I'm one of the ambassadors of, as well as for the use of photos and materials for this presentation. Special thanks to Anne Beauregard, who was the one who sort of pushed me into doing this presentation. And Anne, thank you very much for that. At the Brockton Library, Sue McCormick and Jen Belcher, always very helpful with all my presentations. And then, as I said, Pastor Richard Reed over at the North Baptist Church of Brockton. If you would like to see this, if you didn't see the whole thing, or you know somebody else who might be interested, you can watch a repeat of this presentation. Probably, I don't think it's going to be before next week, but sometime next week, from on Brockton Community Access, Channel 9 and 1080. And BCA has this new high definition channel, 1072. I haven't had a chance to look at it yet, but I'm pretty sure it's going to be anything in high definition is pretty amazing.